it is known that a sample consisting of the values 12, 11.2, 13.5, 12.3, 13.8, and 11.9 comes from a population with density function. So you are given the population density function. You are given the density function basically f of x comma theta, where theta is greater than 0. Find the maximum likelihood estimate of theta. So we have to find what is MLE of theta. Okay, the solution. So students, first of all, we will find the likelihood function. So what is the likelihood function of this parameter theta? So that is product of, so let me write the definition. First I'm writing the definition. This pi symbol is used for the product. Okay, everybody is aware. This pi symbol is used for the product I varying from 1 to n f of xi comma theta. So if I write this in simple words, it is f of x1 comma theta into f of x2 comma theta into so on f of xn comma theta. Okay. Now this f is given, probability density function or density function is given here, and we are also given the values. Like we are given the values 12, 11.2, 13.5, 12.3, 13.8, and 7.9. So we are given the x size basically, right? Okay, so x1 is 12, x2 is 11.2, x3 is 13.5. Okay, so this is sample values now. So x4 is 12.3, x5 13.8, and x6 11.9. So what we will do, so we'll put these values in this x1, x2, xn value. So like because there are only 6 sample values, so we'll take only f of x1 comma theta into f of x2 comma theta and so on up to f of x6 comma theta. Okay, because there are only 6 values in the sample. So let us put these values. So first I will put 12 in place of x in this function. Okay, in the density function in place of x, I will put the 12. If I put 12 here, so I will get theta upon 12 raised to power theta plus 1. In place of x, I am putting the theta in the density function. In place of x, I am putting this x1, x2, xn. Okay, so first I have put the x1, it will be multiplication. Then theta upon x, okay, x raised to power theta plus 1. X is now 11.2 raised to power theta plus 1 and so on, and then we have theta upon last value is 11.9 raised to power theta plus 1. Instead of doing this question in this way, first what you can do, you can find the likelihood function also directly, and in the end also you can put the values. Okay, so both the ways are fine. Whatever you like, you can proceed as per that. Okay, so what is my point? Point is you can do in this way, that you first put the values and then find the likelihood function, or first thing is first we directly find the likelihood function, in the end we'll put the likelihood, we will put these values of sample. So both ways are fine. Okay, so let us first, what is the, we have find the likelihood function. Now we will take log. Step 2, this was step 1 to find the likelihood function, or then step 2 is to take the log both side. If we take log both side, you will get log L is equal to, so log of this. So how many times we have theta here? 6, because there are 6 values. Their voice is breaking. Okay. Let me see if I can make Is it from beginning or in between? Roshan, is it from beginning? From solution. Okay. Okay. Just let me connect with my network strength is full currently. Let me see what I can do. For other students, is the same problem is there? Is it now fine or still it is breaking? Okay, hello. So I have joined from the other network. Let us see if there is an issue from this one. Okay. If there is an issue, please do inform me. Okay. Okay, so now we will find the log L. And for finding the log L, first I am simplifying the function which we have actually. So we have this theta because I have 6 values, right? X1, X2, X6. So X1, X2, X6. So this theta will be 6 times. So theta power 6. And in the denominator, I have different values and these raised to power theta plus 1. So 12 raised to power theta plus 1 into this 11.2 raised to power theta plus 1 and so on. In the end, 11.9 raised to power theta plus 1. Okay, so this is likelihood function. Now we will simplify. We have this is log of likelihood function. Now we'll apply the properties of log. So first property I'm going to apply is log m divided by log m divided by n. So this is m and this whole thing is n. Okay. So what is log m upon log n? Which is log m minus log n. Okay. So this will be log of theta power 6 minus log of this number in the denominator 12 raised to power theta plus 1 into 11.2 raised to power theta plus 1 and so on. In the end, 11.9 raised to power theta plus 1. Okay. So this is the value. Okay. Now again, we will apply the properties of log. So log m power n. So first property I'm going to apply is log m power n. So first the 6 will come in the front. So log of theta. Now I will apply log m1 into m2 into mn. Well, whatever properties I am applying, I want to write here. One I applied is log m power n. So that is n log m. And the other I am going to apply now is log of product is equal to sum of log. Log m into n is log m plus log n. So we will get log 12 raised to power theta plus 1 plus log, so we have minus sign. So in the bracket I can write, we'll get log of 12 raised to power theta plus 1. In the same way, you will get the other also like log of 11.2 raised to power theta plus 1 and so on in the end. Log of 11.9 raised to power theta plus 1. So now this theta plus 1 will come in the front. So we will get 6 log of theta. This theta plus 1 will come in the front of all. So theta plus 1 will be common. So I can take it common. So log of theta plus 1. And we have these so many terms like log of 12 plus log of 11.2 and so on. Okay. So I think it was better that I would have written all power theta plus 1 and I would have sent this all in the beginning itself. But now I'm doing it now. So log of 12 multiplied by 11.2 multiplied with so on in the end 11.9. Okay. So this is log of log L. So this is log L. Step 2 done. So we have simplified the log function. Any doubt, students, in this? Is there any doubt? Instead of this writing these numbers exactly, you can write here x1, x2, x3, x4 up to x6. So this calculation will look better. Okay. When I'm writing these numbers, they are not looking better. Okay. Now I am also finding the product of these numbers at this point. Okay. So I have to use the calculator. What is product of these numbers? So 12 into 11.2 into 13.5 multiplied with 12.3 multiplied with 13.8 multiplied with 11.9. So it is a huge number. Why this much big number is there? Okay. Let me write this. Log of L is equal to 6 log theta minus theta plus 1. If there is any doubt, students, then please tell me. Okay. So log of 366,917.4.4464. Okay, so now third step we will do. Step 3. To find the maximum value of this, we will do derivative of this with respect to the parameter. The parameter here is theta, and we'll keep this derivative equal to 0. So now what is derivative of this? 6 is constant, 6 as it is. Derivative of log theta is 1 upon theta minus derivative of theta with respect to theta is 1. Derivative of 1 with respect to theta is 0. So we'll get only 1. And 1 into this log of this number 3664917.44. Okay, is equal to 0. So you will get 6 by theta is equal to log of 3664917.44. Or you can say theta is equal to log of 3664917.44. Oh, I have 6 upon basically 6 divided by 4. Okay. Any doubt, students? So this is the maximum likelihood value of theta. We should do the double derivative. You can see here. So double derivative will be so this is a double derivative minus 6 upon theta here. Okay, so double derivative. This is step 3. Your question is all till here. You can leave till here, but just for the confirmation, the step 4 is if I do double derivative of this with respect to theta, so it will be minus 6 upon theta square. 6 is positive, theta square is always positive. Because square of any number is always greater than equal to 0 and you have minus sign, so it is less than 0. So double derivative is negative, it means this point is point of maxima. Any doubt, students? Any doubt in this question? If any student have doubt, you can ask. Otherwise, I will move to next example. Next example is this one. Next example. Suppose that 10 rats are used in a biomedical study where they are injected with cancer cells. Okay, where they are injected with cancer cells, and then cancer drug that is designed to increase their survival rate. The survival times in months are 14, 17, 27, 18. So what are these? These are survival times. These are basically survival time of a sample, you can say. These are sample values. X1 is equal to 14, है ना? X2 is equal to 17, X3 is equal to 27, X4 is equal to 18, X5 is equal to 12, X6 is equal to 8, X7 22, X8 13, X9 19, and X10 is 12. Assume that the exponential distribution applies. Which distribution they are talking about? Exponential distribution applies. Give a maximum likelihood estimate of mean survival time. So give the maximum likelihood estimate of mean survival time. Okay, first of all, what is exponential distribution? So what is the density function is the exponential distribution. And the exponential distribution, there is only one parameter, which is beta. Okay, that parameter is beta. And the formula for us 1 upon beta e power minus x upon beta. Everybody is remembering this? Okay, this is from exponential distribution. What is the density function in exponential distribution? So that is 1 upon beta e power minus x by beta, and this is only for positive values of x. Otherwise, it is 0. Okay. So step 1. Now in this question, I will not solve this for the each value by putting all the values. I will put the values in the end. First, I am finding the likelihood function. So what is likelihood function? So it is product of f of x1 comma you have beta here. So x1 comma beta into f of x2 comma beta into so on. How many values I have? So I am given 10 values, right? So I am doing till 10 only. F of x10 comma beta. We can do in general for also, like we can take till xn, and we can do in that way also. So now in place of x, we will put x1, x2, x10. I will put the values in the end, but just I am writing here x1, x2, and x and so on. So 1 upon beta e power minus x1 divided by beta into 1 upon beta e power minus x2 divided by beta, and so on. In the end, 1 upon beta e power minus x10 divided by beta. If you do product, because there are 10 terms I am taking, So 1 upon beta raised to power 10, and base is same e, power will get added. You will get e power, all are in the negative, minus x1 plus x2 plus x10 divided by beta. In all the terms there is a beta. Okay. So now we will take the log both side. So this is our likelihood function for the parameter beta. Now we'll take this step 1. Step 2, we will take log both side. So log of L. Log of L is equal to log of this e power minus x1 plus x2 plus up to x10 divided by beta, and whole divided by beta raised power 10. So first we will apply log m divided by n. So it is log m minus log n. So log of e power minus x1 plus x2 plus up to x10 divided by beta minus log of beta raised to power 10. Okay. So which property I have used here? So I have used the property log of m divided by n is log m minus log n. Okay, now I will use the next property, that log m power n. The power will come in the front. So minus x1 plus x2 up to x10 divided by beta into log e. Okay, so power sent to front. Now log e is 1, that we will do in the next step, minus log m power n. So 10 log beta. So the property which I have used here is log of m power n is equal to n log m. Okay. So this is minus sum of xi, I varying from 1 to 10 divided by beta minus 10 log beta. Okay, so now I will, so log L we have simplified. Step 3. Step 3 is we will do derivative with respect to parameter. Parameter is beta here of log n, and we will keep this derivative equal to 0. What is derivative of this? So the summation of xi does not contain beta, right? What is derivative of 1 by beta? So which is minus minus plus sum of xi as it is, I varying from 1 to 10, and you will get betas here. Minus 10 as it is, derivative of log beta is 1 by beta. So 10 by beta is equal to 0. Okay. So 1 by beta, you can take common and send on other side. You will get sum of xi, I varying from 1 to 10 divided by beta is equal to 10. You can send this, and beta 1 beta will be cancelled out. Like if you want to delay one more step, what you can do here, you can write beta here. So 1 beta will be cancelled out. So beta is equal to sum of xi divided by 10. So sum of 10 values divided by 10. This is the maximum likelihood estimator, and which is completely fine because this beta was a mean, and this equation says that if you want to estimate the mean of exponential distribution from a sample, then you can use a sample mean. It is a maximum likelihood estimator. Okay, it means it is a good way to, sir, can you put the value of xi? Can we put? Yes, yes. The value of log value of log is 6.56. So which question? Okay, in the previous question, I think Roshan have answered. Okay, and in this question, beta will be the value of beta will be sum of these 10 values which are given to us. We can directly put also. Okay, I am doing in the end. You can also, in fact, you can do it for the journal also. Like if in the exam they ask you find the maximum likelihood estimator of beta in the exponential distribution. So what you will do in place of x1, x2, x10, you will take n random sample x1, x2 up to xn, and then you will solve same way. I am doing till 10, you will take till n. Okay, xi, sum of xi is 162. Okay, so sum of xi values. Okay, so Notion I found this that beta is equal to sum of xi, and sum of xi values is let me for the timing write these values. So 14 plus 17 and up to 12. 14 plus 17 plus so on up to 12 divided by 10. So sum is Roshan is telling is sum is 162. I hope it is correct. Divided by 10. So mean or average is 16.2. The maximum likelihood estimator tells that the maximum likelihood estimate for this exponential distribution is 16.2. The average survival time is 16.2. Okay. Any doubts, students? Can we move to next question? Let me do the next question. If there is no doubt, maximum likelihood is important. Okay. Find the maximum likelihood estimator of parameter theta of the population having density function, this one. So you are given the density function f of x comma theta is 1 plus theta x power theta. So this is given. So we have to find maximum likelihood estimator. So first let us find the likelihood function. Likely, let me not write the full name. So likelihood function L theta. What is the likelihood function? So it is f of x1 x1 comma theta f of x1 x1 comma theta into f of x2 comma theta and so on up to f of xn comma theta. So where x1, x2, xn is a random sample. Let x1 comma x2 and up to xn is a random sample. So in this question we are not given the values. We have taken a random sample x1, x2, xn, and we will find the maximum likelihood estimator for this parameter theta. Means if I want to if I want to find how should I try to estimate the value of theta from this sample? What is the best way to estimate the value of theta? Okay, so how we can do it? Okay, what is the best possible way that is given by this likelihood estimator we are going to find. So let us put these values x1 in place of x in this function, likelihood function. So we'll get 1 plus theta into x1 raised to power theta. Then put again x2 in place of x. So again you will get 1 plus x2 raised to power theta, and so on. In the end you will get 1 plus theta into xn raised to power theta. Now let us simplify this. 1 plus theta, 1 plus theta, 1 plus theta is multiplied how many times? N times. So 1 plus theta raised to power n, and x1, x2, xn, all these have same power theta. So you can write this as x1 into x2 up to xn whole power theta. So this is L theta, okay, or likelihood function. So step 1 done. Now we will do step 2. In the step 2, we have to take the log. To simplify this, the log of L is equal to log of 1 plus theta raised to power n x1 into x2 and so on into xn raised to power theta. So first apply log m into n. This is m, this is n. So log m into n, which is log of m into log of n. Now I will apply the property of log m power n. So power will come in the front. So n log 1 plus theta, and then here also theta will come in the front. So theta log of x1 into x2 up to xn. Okay, students, here also we can further apply the property of log, but it is not required. So like you can find the log m log x1 into x2 into so on xn is equal to log of x1 plus log of x2 and log of xn in the plus. But this is not required. Okay, why it is not required? Basically, we want to find the estimator for theta. We will do derivative with respect to theta. So this x1, x2, xn has no role in the derivative. Okay, so our main purpose is to simplify this basically theta thing. Okay, so step 3 now, we will find derivative of this log L, and we will keep this derivative equal to 0 so that we can find the point where this function is maximum. So n as it is, this n as it is, derivative of log 1 plus theta with respect to theta. So derivative of log is 1 upon 1 plus theta into derivative inside function. Derivative 1 is 0, derivative theta is 1. So you will get only this thing. And this is, you are doing other thing does not matter. Derivative of theta with respect to theta is 1. So you will get log of x1 into x2 and up to xn is equal to 0. Okay. Now we can send this on right side. Now we can send this on right side. We will get n upon 1 plus theta is equal to minus of log x1 into x2 up to xn, or you can say 1 plus theta is equal to n minus n divided by log of x1 x2 up to xn, or theta is equal to minus 1 minus n divided by log of x1 x2 up to xn. So this is what we are getting. Is it fine? Any doubt? Have you done it correctly? Any kind of doubt in this question? If any student have doubt, then you ask. Otherwise, I am trying to re-verify all steps are done correctly or not. Yes, everything is fine. Okay. Okay, so let us move to next question. Next question is, so this next question is a little bit lengthy and I will say a little bit tough also. Okay, so it is lengthy, we can say, better word is lengthy. In random sampling from normal population n mu comma sigma square, find the maximum likelihood estimated for mu. The first part when sigma square is known, and second part is sigma square when mu is known, the simultaneous estimation of mu and sigma square. So first let us do these first two parts. The normal population is here. Now what is density function in the normal distribution? F of x comma mu comma sigma. There are two parameters in normal distribution basically. Okay, and we have to find the maximum likelihood estimator. First I'm writing the density function of normal distribution. The density function, if you remember, is 1 upon sigma root 2 pi e power minus x minus mu divided by sigma whole power 2, and I think half was there. Okay, so is it correct? If you have the notes, can you verify that we have written correct function for the normal distribution or not? Okay, now we will find the likelihood function. So likelihood function of mu and sigma square. Okay, so I'm writing here sigma square for the time being. Okay, because we want to find the maximum likelihood estimator of sigma square, not the sigma. Okay, so it is product of f of x1 comma mu comma sigma square into f of comma square and so on of xn comma mu comma sigma square. Okay, so now we will put the value instead of x, we will put x1, x2 and xn in this function, in the density function. Student, where there is a query like, do we need to remember these distribution functions of uh, different distributions? Like, should we need to remember the density function for exponential function? Should we need to remember the density function for exponential distribution? So if you want to solve this question, there is no other option seems to be true. And like in the gamma and exponential distribution, we have to remember the function because otherwise we will not able to find the probability. Okay. In the normal distribution, for this question we have to remember. Otherwise, in the normal distribution, the values are given, but if you have to do the question of maximum likelihood estimator, then there is no other option except then remembering this formula of the probability density function. So first I will put x1, 1 upon sigma root 2 pi e power minus half x1 minus mu upon sigma whole power 2 multiplied with 1 upon sigma root 2 pi e power minus half x1 minus mu upon sigma whole power 2 and so on, and then 1 upon sigma root 2 pi e power minus half, x2 should be the, and xn minus mu upon sigma whole power 2. Okay. So now this sigma n times. Okay. So we can write this as 1 upon sigma raised to power n root 2 pi root 2 pi root 2 pi n times. So these are getting multiplied. So root 2 pi raised to power n. Okay, and base is same, e, so power will get added. We will get e raised to power minus half, and we will have sum of these, right? So I can write this as using summation. Sum of these I varying from 1 to n xi minus mu upon sigma whole power 2. So if you want to write individually, you can also write. I prefer writing in this way. It saves us space as well as time also. So this is L of mu comma sigma square. This is likelihood function. Now we will take the log as usual. So this was step 1 to find the likelihood function. Now step 2, we will take log both sides. We will find log L. So log L is equal to log of this 1 upon sigma power n, or you can say 2 pi raised to power n by 2, because under root means power 1 by 2, right? So and power n, so n by 2 power, and e power minus half sum of this xi minus mu upon sigma whole power 2. Okay, so this is equal to now we will simplify. So first I am using log m upon n property. So this I am considering as a m, and this I am considering as n. Log m, the log of e raised to power minus half sum of xi minus mu upon sigma whole power 2 minus log of sigma power n into 2 pi raised to power n by 2. So again I will apply log of m into n property, then I will apply log m power n. So in the first I am applying log m power n. So this power will come in the front, minus half sum of xi minus mu divided by sigma whole power 2, I varying from 1 to n. This is log L, and log e is 1. So I am not writing that. Log e is 1. Okay. Minus log m into n. So log m into n is log m plus log n. But you have minus sign, so log m minus log n. Then log m power n. So this n will come in the front. You get log sigma minus n by 2 log of 2 pi. So this is the log L. Now step 3. Step 3 is we will do derivative with respect to. Now in the step 3, so the question is whether you are you finding the maximum likelihood of sigma square, or are you finding the maximum likelihood mu. So in the first part we are finding the maximum likelihood of mu. So we will do derivative with respect to mu. Okay, because I want to find the maximum likelihood estimator for mu in the first part. So I will do partial derivative of with respect to mu of the log n. So let us do the derivative. So minus half is constant, it will remain as it is. Sum as it is, I varying from 1 to n. So first this power will come in the front. So this 2 will come in the front. Xi minus mu divided by sigma. Subtract 1 from the power. So 2 minus 1. 2 minus 1 is 1 into derivative of this inside function with respect to mu. Derivative of xi with respect to mu is 0. Derivative of mu with respect to mu is 1. So we will get here minus 1 upon sigma. And this term do not contain mu. This term also do not contain mu. So derivative of this is 0. Derivative of this is 0. Okay. And we have to keep this derivative equal to 0. So this 2, if you take this 2 out, this 2 and this 2 will be cancelled out. And what we are left, this minus minus plus. Okay. Minus minus plus, this minus and this minus will be plus. this sigma into sigma. Sigma square you can take common. What I'm left with 1 upon sigma square sum of I varying from 1 to n xi minus mu is equal to 0. Sigma square should be here. Now send the sigma square on other side, it will be 0. And here on the left side you will get sum of xi, I varying from 1 to n, minus sum of mu n times. So mu plus mu plus mu n times. So you will get n times mu is equal to 0. Now send this n mu on this side. So you will get n mu is equal to sum of xi, I varying from 1 to n, or mu is equal to sum of xi divided by n. So it means in the normal distribution also, if you want to find the maximum likelihood estimator of mean is sample mean. If you want to guess the mean of normal distribution, then the best way is you find the mean of sample, you mean of observation, and that will be maximum likelihood estimator of the population mean also. Okay, means like if you have if you have these values x1, x2, xn, what is the best way to estimate the population mean? So the answer is given by this maximum likelihood estimator for that is some means mean of that, basically mean of this. If you want to estimate the mean of population, whole population, you can you should use the mean of the sample. Okay. Any doubt in the in this first part? Now in the second part, we'll find sigma square when mu is known. We will find the maximum likelihood estimate of sigma square when mu is known. Means now we will do derivative with respect to sigma square. Earlier we have done derivative with respect to mu. Now we will do derivative with respect to sigma square. So step 4, not step 4, basically. So now we will find part 2. And the part 2 we have to find the max MLE for sigma square we have to find. So first of all, what is the likelihood function in terms of sigma square? It was log or log of L. First of all, log of L. Second part we will not repeat now. It was minus half. We can write as minus half. So the sigma square also I am taking out. 1 upon sigma square I am taking out. Sum of xi minus mu whole power 2, I varying from 1 to n log sigma minus n log sigma, and minus n by 2 log 2 pi. Now I have to do a derivative of this with respect to sigma square. Okay. If I ask you to do derivative with respect to sigma, that is simple. You can do easily. But if I ask you to do derivative with respect to sigma square, you don't know how to do it. Okay. So that is why to make the task easy, what I am doing, I will convert everything in terms of sigma square, and then I will put sigma square is equal to t. So let me write what I am going to explain. 1 by 2 as it is, sigma square as it is, sum of I varying from 1 to n xi minus mu whole square as it is, minus. So here I have sigma only. I want sigma square here. Okay, but I cannot magically put sigma square here. So what I will do? So I will do power 2 and then whole power 1 by 2 minus n by 2 as it is, log 2 pi as it is. Why I want to make sigma square here? Because I want to do derivative with sigma square with respect to sigma square. Now this log sigma square power 1 by 2, the power 1 by 2 will come in the front. So it will be minus 1 upon 2 sigma square sum of xi minus mu whole power 2 I varying from 1 to n minus n by 2 log of sigma square minus n by 2 log of 2 pi. Any doubt, students? So the doubt would be why I'm converting this sigma in terms of sigma square. Why we are doing this here? Because I have to find the maximum likelihood estimator of sigma square. That is why I'm trying to convert wherever I have sigma, I am making it sigma square. And so that I can find the derivative of this with respect to sigma square easily. Now sigma derivative with respect to sigma square, we don't know how to do it. So in place of sigma square, what I am doing, I am putting sigma square is equal to t, so that we are not confused. So log of L, this is equal to minus half t. In place of sigma square, I am putting t, sum of xi minus mu whole power 2, I varying from 1 to n, minus n by 2 log of t minus n by 2 log of 2 pi. Okay. Now I will do derivative of this to find the maximum likelihood estimate of t. T means sigma square. What is the derivative of this 1 by t with respect to t? So it is minus 1 by t square. So minus minus plus 1 by 2 t square. This as it is, because this does not contain t, minus n by 2 ht. Derivative of log t with respect to t is 1 by t. And this does not contain t, so derivative of this is 0. Partial derivative, it is what we are doing. Okay. So we have to keep this derivative equal to 0. Now send this n by 2 t on right side. So you will get 1 upon 2 t square sum of xi minus mu whole square, I varying from 1 to n, is equal to n by 2t. So this 1, 2 will be cancelled out, 1 t will be cancelled out. Send the t on this side, send the n on left side. So you will get t is equal to sum of I varying from 1 to n xi minus mu whole square divided by n. So if you, what is t now? T is sigma square. If you want to estimate sigma square, so the best way, sigma square is variance. If you want to estimate the variance, the best way is estimate using the sample variance. And the maximum likelihood estimator of sigma square is this sample variance. This is called small s square, if you remember. Okay. So maximum likelihood estimator of sigma square is small s square in the normal distribution, and maximum likelihood estimator of mean is mean itself, mean of the sample mean. Okay. So from here we noticed MLE of mean is a sample mean x bar, and MLE of variance is sample variance small s square. Next question. So I think I have given all the important examples. If you find some example in the previous year question paper from this chapter, which you are not able to do, or some issue is there, you can put here. Okay, I will try to solve that. Okay. Okay, so one more problem, I will give you an exercise. I will give you the hint for that. So this problem I am giving you to as an exercise. After that, we will start the unit 6. And unit 6 is the hypothesis testing. There will be 4-5 type of test, and we just have to apply the test in the problem. Okay. To prove that the maximum likelihood estimate of parameter alpha of the population density function of the population having density function 2 by alpha square alpha minus x So you are given the density function. So f of x comma alpha. Earlier we used to write fx only, but now I am writing alpha also, na? Because we have to tell what is the parameter there. Okay. So 2 upon alpha here into alpha minus x, where this x is between 0 and alpha. This is given the question. Now for a sample of unit size 2x, it means there is only one sample, that is, and size of that sample is 2x. So the value of x1 is 2. There is only one value in the sample. Okay, x being the sample value for a sample of unit size. For a sample of unit size is 2x. Okay, we have to show it. Sorry, not this. What we have to show, that the MLE, I have not read the complete line, prove that the maximum likelihood estimate of parameter alpha, MLE of alpha, having the density function this, for a sample of unit size is 2x. So we have to show that MLE of alpha is 2x. So this we have to show. For a sample of unit size means there is only one value in the sample, only x1 is there. So we have to show that if there is so x being the sample value, if the x is sample value, so not x1, they are taking x itself. So there is only one value, the value is x, and we have to show the maximum likelihood estimate of this alpha is 2x. Showed also that the estimate is biased, and we also have to show that this is a biased estimate. Means biased means expectation of this 2x is not equal to alpha. Okay, so these two things we have to show. Now because there is only unit, this sample is of unit size. Okay, this sample is of unit size and x is the value of the sample. So means x1 is equal to x. There is only one value and that is x. X is a sample value. What is the likelihood function? So here we have parameter alpha. So likelihood function, if you know the definition, x1 into x1 comma alpha into f of x2 comma alpha and so on, f of xn comma alpha. But now there is only one sample. It means only one value is there, x1. So we have to take only one function f of x1 comma alpha, and that x1 is also equal to x. So just put here. So you just don't need to put anything. You directly given the likelihood function 2 upon alpha here, alpha minus x. So directly likelihood function is given in this question. Okay. So likelihood function is given. You will find the log L is required. You can find the log L. So step 1, step 2, to make your calculation easy, you can find the log L. So log of 2 upon alpha here into alpha minus x. Then you simplify this, then do derivative, keep the derivative equal to 0. You will find the value of alpha will comes out to be 2x. This you have to show in the step 3. And after that, you have to also show that this is a biased estimator. So do you want me to complete this question, or you will do it? Should I move to unit 6, or you tell me, students? Should I complete this question, or if there is any doubt in this question, first of all, you tell me. If there is any doubt, then do tell me. Do you want me to complete this question, or you will complete it? Both part you have to do. Sir, unit 6. Ayush is saying unit 6. Okay. Okay, so let us start unit 6. Okay. So unit 6 is hypothesis testing. Hypothesis testing.